Every 3 years, America's giant willow fields explode into activity. Massive machines sweep across the landscape, slicing entire rows of shrubs in seconds, shredding them into biomass fuel, and sending them into processing plants where they're transformed into clean, renewable energy. What used to be a forgotten species is now becoming one of America's most promising climate solutions. Today, we're going inside a harvest like no other. Where trees grow like crops, machines cut entire forests in hours, and science brings new life to sustainable energy. Welcome to the supergiant willow harvest. Before we begin, remember to like, subscribe, and turn on the bell, because you won't want to miss what comes next. Why willow? Because it can grow 8 to 12 feet in a single season, reach full harvest size in 3 years, and then regrow from its own stump. That means a single planting can be harvested 7 or 8 times, producing biomass for 20 years. No replanting, no reseeding, just a cycle of growth, harvest, regrowth, and more harvests. Willow is the perfect climate crop. Its deep roots hold soil in place, preventing erosion. It absorbs large amounts of carbon dioxide, up to 10 tons per hectare per year. It requires no fertilizer once established and minimal irrigation. And unlike corn or soy, willow can grow on land considered too poor for food crops. Farmers call it the tree that grows where nothing else wants to. And because it regenerates from its base, willow can be cut to the ground and come back even stronger, like a perennial grass, but made of wood. This remarkable feature is what makes the giant willow harvest possible, a harvest where forests grow like fields and trees behave like renewable fuel plants. And now it's time to step into the fields where the magic happens. Unlike regular tree nurseries that grow saplings, willow plantations begin with cuttings, pieces of stem taken from a healthy willow parent. These cuttings, usually 8 to 10 inches long, are collected in winter when the trees are dormant. Each cutting contains enough stored energy to sprout roots and leaves once spring arrives. Farmers use a machine that looks a bit like a corn planter, except it feeds cuttings into the soil vertically. As the machine moves forward, it pushes each cutting into the ground exactly 8 inches deep and exactly 2 feet apart. Willow fields are planted in long, uniform rows with tight spacing that maximizes biomass. 6,000 to 7,000 stems per acre. Once planted, willow grows explosively. In the first year, stems reach 4 to 6 feet. In year 2, they shoot up even faster. By the 3rd year, a dense forest of slender stems, each about 2 inches thick, stands ready for harvest. These willow plantations don't look like typical forests. The stems are thin and flexible, swaying like giant grass in the wind. But while they seem delicate, they hold enormous energy potential. Each acre can produce 5 to 10 tons of dry biomass per harvest, enough to heat homes, generate electricity, or be turned into biofuels and pellets. During the growth period, willow requires almost no maintenance. Farmers may mow between rows to control weeds, but the trees themselves grow with little help. No fertilizer, no pesticides, and no irrigation, just sunlight, rain, and time. But the real magic comes after the harvest, because unlike other energy crops, willow doesn't die. When cut, each stump, called a stool, responds by sending up a burst of new shoots. Within weeks, green stems emerge again, beginning a new 3-year cycle. This regenerative ability means the same field can be harvested repeatedly for decades. It's one of nature's most efficient, renewable systems. A tree designed not for lumber, but for endless cycles of clean biomass. And now comes the most spectacular moment. when the machines arrive. When the third autumn arrives, willow farmers prepare for a harvest unlike anything in traditional agriculture. The machines used here are immense, hybrid harvesters adapted from European forage harvesters used in corn and sugarcane fields. But instead of cutting grass, these machines cut entire rows of trees. The star of the harvest is the cut and chip harvester. It moves through the field with a deep mechanical roar, its forward blades slicing through thousands of willow stems at the base. As the stems fall, powerful rollers pull them inside the machine, where rotating knives instantly shred the wood into small chips. Imagine cutting down a forest and processing it into fuel, all in one pass. All in real time. The chips flow through a chute and into a tractor trailer driving beside the harvester. Every few minutes, the trailer fills with steaming, freshly cut willow chips. The tractors rotate like clockwork, switching out full trailers for empty ones without stopping the harvester. The entire operation moves like a factory on wheels. A single machine can harvest 20 to 30 tons of willow per hour. Entire fields that took 3 years to grow can be harvested in just a day or two. From above, drones capture the breathtaking movement. Long straight rows collapsing and disappearing behind the harvester, leaving clean-cut stumps that will sprout again in spring. The willow harvest is unique in agriculture because the crop regenerates. No plowing, no reseeding, no tilling, just pure renewable growth. But the chips aren't useful in raw form. They must go through a giant processing system to become usable fuel. And that brings us to the next phase of this incredible journey. Once harvested, willow chips are transported to large biomass processing centers. These plants look a bit like lumber mills, but their purpose is very different. Instead of making boards or furniture, these factories turn wood into fuel. First, the willow chips are dried. Freshly harvested willow contains up to 50% moisture, too wet for efficient burning. The chips are placed inside giant drying drums, rotating cylinders heated with low-temperature waste heat from nearby industrial plants. As the chips tumble, warm air removes excess moisture and reduces the weight by half. Once dried to 15 to 20% moisture, the chips are screened. Oversized chunks are rechipped. Dust and bark particles are separated and used as soil amendments or compost. Next comes pelleting, a step that compresses the chips into dense cylinders. The dried willow enters a pellet mill, where it is squeezed through small holes at high pressure. The heat from compression binds the natural lignin inside the wood, forming smooth, shiny pellets with no chemicals or glue. These pellets are packaged into bags for home heating, stored in bulk for biomass power plants, or transported to industrial boilers. Because willow burns cleanly and consistently, it's ideal for energy production. Some facilities don't pelletize the willow at all. They feed chips directly into biomass power stations, where they fuel turbines that generate electricity. In upstate New York, entire communities receive clean energy from willow-fueled plants. Even the leftovers from processing, dust, fibers, and bark, are composted or used to restore soil health on nearby farms. Nothing goes to waste. If you enjoyed this journey through America's renewable energy forests, make sure to like, subscribe, and turn on the bell, because we have many more incredible stories coming your way. Stories of nature, stories of industry, stories of how everyday materials are grown, harvested, processed, and transformed into the world we rely on. Every year, millions of trees are harvested, processed, and transformed into the lumber, paper, and building materials that shape modern life. Welcome to the supergiant logging operation in America, where science, engineering, and nature meet in a mind-blowing process that turns living trees into the products we use every day, while ensuring the forests keep growing strong. Before we dive in, don't forget to like, subscribe, and hit the bell icon to explore more amazing behind-the-scenes stories of how the world's biggest industries actually work. The United States is one of the largest timber producers in the world, managing over 750 million acres of forest land. Logging isn't new here. It began over 200 years ago, fueling the construction of the nation's first railways and towns. But today's industry looks nothing like the past. Modern American logging is a blend of robotics, GPS-guided machinery, drones, and data analytics, ensuring every tree harvested is accounted for and every area replanted. Each year, the U.S. produces over 400 million cubic meters of timber, feeding into construction, furniture, paper, and even renewable energy. From the pine forests of Oregon to the hardwood trees of Alabama, this industry never sleeps. Before a single tree falls, the operation begins from the sky. Drones scan thousands of acres, mapping terrain, tree density, and species composition. Technology helps foresters plan which areas to harvest, which to protect, and how to replant efficiently. Then, crews on the ground mark boundaries, access roads, and zones for sustainable harvesting. Nothing is random. Every log is part of a carefully calculated 20 to 40-year forest cycle, ensuring nature always recovers. This is where the action begins. Massive feller bunchers roll into the forest. Each one a steel beast with hydraulic claws that can grip, cut, and stack entire trees in seconds. One operator can harvest hundreds of trees per hour using GPS precision and onboard computers. The machines are designed for efficiency, reducing waste, minimizing soil disturbance, and keeping operators safe inside air-conditioned cabins. Once felled, the trees are stripped of their branches by delimbers, then cut into exact lengths using computer-controlled saw heads. These machines don't guess. They scan each log using laser sensors to measure volume, diameter, and quality in real time. The felled logs are loaded onto giant logging trucks, capable of carrying up to 40 tons per trip. These trucks rumble down temporary forest roads to massive sawmills, the next stage in this billion-dollar process. At the mill, logs are unloaded and sorted by size and species. They go through debarking machines, high-speed saws, and computerized scanners that optimize every cut for maximum yield. From one tree, America gets construction lumber, furniture panels, veneers, and pulp for paper. Nothing goes to waste. Even sawdust is captured and turned into biomass energy or pellet fuel for heating homes. Every log, every chip, every splinter gets used. For every tree harvested, 1 to 3 new trees are planted. This isn't optional. It's law in most states and standard practice for major logging companies. Foresters return to the same sites months after harvest, planting new seedlings and protecting them from pests and fire. The result? The US actually has more forest cover today than it did 100 years ago. A testament to modern sustainable forestry. So yes, this is a massive industry, but it's also a model of balance between economy and ecology. The future of logging is not about bigger machines, it's about smarter ones. Artificial intelligence helps mills optimize every cubic inch of wood. Autonomous harvesters and electric trucks reduce emissions and increase safety. Some companies are even experimenting with carbon-negative logging, where replanting and soil restoration absorb more CO2 than the operation emits. Meanwhile, remote sensors and drones monitor forest health, track wildlife, and detect illegal cutting, turning American forests into one of the most closely watched ecosystems on Earth. This is logging reimagined, cleaner, greener, and more data-driven than ever before. The U.S. timber industry supports over 1 million jobs and contributes more than $300 billion annually to the economy. Timber is used in housing, packaging, furniture, renewable fuel, and even aviation composites. But its greatest value may not be in profit. It's in how it demonstrates the possibility of sustainable industrial growth. As the world pushes for greener materials, wood remains one of the only renewable building resources that grows stronger the more responsibly it's managed. And America's logging operations, from Oregon's towering pines to Maine's maple forests, are leading the charge. If you're amazed by how forests transform into the materials that build our world, don't forget to like, subscribe, and hit the bell icon for more jaw-dropping stories from the world's biggest industries. In this video, we'll step inside the supergiant plywood industry, exploring how raw logs are stripped, peeled, dried, layered, glued, pressed, and finally cut into the panels that shape our world. We'll also uncover the history of plywood, from its humble beginnings in ancient Egypt to the mega factories of today. So buckle up, because this is the epic process of how layers of wood become strong boards, in one of the most fascinating industries you've probably never seen. Long before giant factories and high-speed machines, the idea of layering thin sheets of wood to make something stronger was born. Historians trace plywood's roots all the way back to ancient Egypt, around 3,000 years ago. Egyptian craftsmen glued thin veneers of precious wood onto cheaper materials to create durable furniture that looked beautiful, but didn't require massive solid logs. The concept resurfaced in 18th century Europe, where fine furniture makers experimented with thin layers of veneer for both aesthetics and strength. But plywood as we know it truly took off during the Industrial Revolution. In 1865, Emmanuel Nobel, father of Alfred Nobel, who later created the Nobel Prize, invented a rotary lathe to peel thin sheets from logs. This innovation changed everything, making plywood affordable and scalable. By the early 20th century, America embraced plywood for construction. During World War II, it became a critical material for military airplanes, boats, and barracks. Strong yet lightweight, plywood proved to be a miracle product. After the war, the housing boom in the U.S. accelerated demand, and plywood became a staple for walls, flooring, and roofs. Today, the global plywood industry produces over 100 million cubic meters annually. Mega factories across the US, China, and Europe can each churn out thousands of boards per day, feeding construction, furniture, and even shipbuilding industries. What started as an ancient craft is now one of the most powerful industries shaping modern life.